All right, for adding or subtracting radicals, they have to have the same index and the same radicand. All right, so the index is what goes in that little trough or cranny in the radical symbol, and the radicand is what we're taking the root of. That's what's under the radical. So here are a few examples and non-examples. In our first one, they have different indices, so that can't happen. We cannot do anything with those. We can't add them. These ones have different radicands, though they're both square roots. What's under the radical is different, so we can't add them. The last one have the same index and the same radicand, so we can add them. We have one root x and two root x's, so that's 3 roots of x. Here, if we had 3 and 11 roots of 7, we add those together and get 14 roots of 7. In our next example, they're the same index of 3 and the same radicand of 5. So 3 of those plus 8 of those is going to be 11 cube roots of 5. Our next one, we cannot add them. So that's done. That's as simplified as possible because they have different indices. Pardon. Now, sometimes you have to simplify the radicals first because they don't look like they can be added, but they actually can. So here we simplify root 27, simplify root 75, and we see that they both are the square root of 3, something times the square root of 3. So we're going to do 3 plus 5 is 8 square root of 3. When we're multiplying, we have to have the same indices, so it has to be both square roots or both cube roots or whatever, but the radicands will get multiplied. So we always simplify before we multiply, and then the coefficients will multiply each other. So my general rule is this. If I have something, A is outside the radical, X is under the radical, B is outside, Y is inside, we can multiply the outsides together, A times B, and multiply the insides, X times Y, and that remains under the radical. So our first case, radical 5 times radical 6 is radical 5 times 6, which is radical 30. You're going to want to make sure you check to see if it can be further simplified. There's no perfect square that goes into 30, so it's done. Radical 9, rad 16, we're going to simplify those first. Simplifies to that, multiplying 3 and 4 gives us 12. Here we're going to distribute just like we normally would. Root 3 times each of those. Now notice the order I wrote these in. We always, even though it was root 3 times 3, we write the non-radical number in front. And then root 3 times root 5 is root 3 times 5 is root 15. Those are different radicals. They cannot be simplified any further. Another good example here, copy this one down. Rad 12 times rad 6. I'm going to simplify the radical 12 first. That gives me 2 root 3 times root 6. Now when I multiply those, look at the root 18. You can actually simplify that further. So 9 goes into 18, so I simplify it thus. Have a nice day.